Good afternoon, students. Today we are going to discuss about the practical chemistry, and I want to emphasize the importance of practical chemistry in your competitive examination. So, say for example, the current May NEET 2026 examination. So, you observed nearly about 4 questions from the practical chemistry. And when you consider the practical chemistry, you have 3 parts of practical chemistry. So, for example, organic practical chemistry, inorganic practical chemistry, and physical practical chemistry. Actually, organic practical chemistry, you'll be learned that from the GOC, General Organic Chemistry itself. And the physical chemistry also, so you learn from the physical chemistry chapters. And most probably, the one you have to study separately is the inorganic chemistry. And most importantly, in this current NEET 2026 May examination, you have 2 questions from this inorganic practical chemistry. So we want to discuss some of the important concepts, so which you have to know while answering the questions. So today I'm going to discuss about the inorganic qualitative analysis. And when you consider the inorganic qualitative analysis, you will be given with the unknown salt, and they ask you to identify what is the acid radical and the basic radical which is present in the salt. You know what is an acid radical, right? So this is the anionic part of that is said to be the acid radical, and the cationic part is said to be the cationic part is the basic radical, and you have to identify what is the cation and the anion present in the given salt. And for that, you have to follow a chronological order of procedure, so which we usually say that as the salt analysis. And the procedure, it usually involves 3 important steps. So the first one, it is said to be the dry test, or it is said to be the preliminary test, where you have to analyze the salt, but you cannot confirm the presence of any of the cation or anion, but we can get an idea about the cations and anions present in that if it is the preliminary test. The next one, you have to go for the wet test and the confirmatory test in order to confirm what kind of cation and anion is present in the salt. So we will start with the qualitative analysis and the chronological order of the procedures. As I told you, it contains the preliminary test and the wet test and the confirmatory test. Actually, in your examination and syllabus, we have these kind of anions and cations to be tested. And this is the syllabus which is given for you by NTA. So except these ions, you don't have much of any of the salt to be analyzed. Anions you are going to analyze is CO3 2 minus, which is carbonate, S minus, this is sulfate, NO2 minus, so which is nitrite, Cl minus, chloride, Br minus, bromide. So F minus, it is given wrong there. Actually, it is not F minus, only I minus, iodide. And you know very well, fluorine, the chemistry is highly reactive. We cannot study that salt. And NO3 minus, it is nitrate, and SO4 2 minus, it is the sulfate. And the cations given in the syllabus is ammonium, so which is the 0th group cation. So lead, so first group. Copper, it is a 2nd group cation. Aluminum and iron is the 3rd group cations. Zinc and nickel is the 4th group cations. Calcium and barium is the 5th group cation, and the 6th group cation is magnesium. And you have to analyze these anions and cations. So using that chronological procedure, as I told you, so it involves the preliminary test, the wet test, and the confirmatory test. So preliminary test, as I told you, it won't give any conclusive confirmation, but so the wet test, you can get an idea whether this is the cation and anion which is present. And you will go for the confirmatory test and confirm the presence of the identified cations and the anions. So we will start with the preliminary test. In the preliminary test, so you have the physical examination. The first one, it is a physical examination. So physical examination, you see, you have to you can view the substance, and you can identify the color and what may be the order you get from the substance. So from that, you can have a basic idea about the salt which is given. So if it is a blue or green in color, the presence of the salt may be contain copper. So if it is brown, it is the confirmation of the presence of iron. And if the salt is green in color, it confirms the presence of nickel. And if the substance is white in color, and most probably white in color, and it smells like ammonia, so if you want to observe the odor, you cannot take it directly to your nostril. Actually, you have to keep the plate, so watch glass away from you, and you have to try to observe what kind of odor you obtain from that substance. So don't take any of the chemical substance directly to near to your nostril. So this is physical examination, and that will give you about some of the basic ideas. So the next preliminary test we are going is the dry test. You have to take the substance and put it in the dry test tube, and you heat it. And when you heat it strongly, you observe some of the changes, and using that changes, you can get some of the idea about the salt which you have. So if you observe any of the colorless gas is evolving from the salt, then it is carbonate. And if you get rotten egg smell, colorless gas with a rotten egg smell, it may be sulfide. If you observe it to be greenish yellow in color, so it is chloride. Or if you observe any of the reddish brown vapors to be evolved, it may be nitrate or it may be bromide. So later we can distinguish whether it is bromide or it is nitrate. And if the color of the vapor is lilac, which is violet in color, then it is iodide. And these two tests are very basic analysis. So the next one, we move on to the flame test, or borax bead test, or the charcoal test. And these tests, this will involve some of the basic chemical components which is involved in the process, or the chemical process involved in the process. So for example, if you consider it to be the flame test. So flame test, we usually, if it is flame test, you take some amount of the salt in a watch glass, and you add few drops of concentrated HCl, and you make it as a paste, and you introduce that paste into the Bunsen flame as it shows here. So the Bunsen flame usually that is blue in color, and you introduce that into the flame, and the salt which present in the tip of the glass rod, so it will burn with a characteristic color, and from that characteristic color you can identify the salt. And the basic principle of this test is actually, it's a flame test, right? So when you mix that into concentrated HCl and introduce into the flame, so it acquires the energy, and the valence electron will undergo transition from the valence shell to the next higher level, next excited state, and this is what we learned as electronic transitions. And when the electron it return to the ground state, if the wavelength of the radiation or the energy of the radiation lies in the visible region, then you will observe it as a colored substance. The electronic transitions, if it lies in the visible region, it is observed as a colored radiation, and that's what we observe here. So if it is a barium, it appears as an apple green in color, and if it is calcium, you will get brick red color, and if it is copper, this test you will get a blue green color, flame. So from the color of the flame, we can identify whether this is the salt which is present or not. So this is flame test. The next one, it is borax bead test. And borax bead test also, it involves some of the most basic chemical reaction that we have to know. So say for example, borax is nothing but it is Na2B4O7. Okay, so about 10 times of water. And when you heat this strongly, it will lose the water of crystallization. It will lose the 10 moles of the water of crystallization, and it gets converted into sodium metaborate and boric anhydride. So sodium metaborate is NaBO2 plus B2O3. So that is sodium metaborate and boric anhydride. And these two mixture is actually a glassy bead. So we observe that color beads like. So you'll observe a glassy bead, which is a colorless bead. And if you mix the salt which is given to you with this glassy bead, and introduce that into the luminous flame or the non-luminous flame. Luminous flame or the non-luminous flame, you can identify that from the color. So which is said to be the oxidizing flame and the non-oxidizing flame. So if the flame is like this blue in color as shown in the picture, then it is said to be the oxidizing flame. So because you have the enough oxygen for the fuel to burn, and you will get an intense blue color flame. And sometimes even in your home you could have observed, when you switch on the gas, sometimes the blue color of the flame will be blue, and sometimes it will be yellowish to reddish orange in color, and that is said to be the reducing flame, because the oxygen is not sufficient to burn the fuel, and you will get that yellow reddish in color, and that color is actually, it shows that oxygen is not sufficient. And when oxygen is not sufficient, so it may the reason is the burner is not correct, so it's not properly cleaned, or some dust particle may be in between that, it won't provide sufficient oxygen for the burning of the fuel. And if you introduce this glassy bead, so that is metaborate and boric anhydride, so into the oxidizing flame or the non-oxidizing flame along with the metal salt, that will burn with a characteristic color, and that shows the presence of the salt, so which you have to identify. And in your syllabus you have so very few cations and anions. So if in this test, if you mix your salt with a boric anhydride, so it will form metal metaborate, which is the MbO2, so BO2 twice. So that metal metaborate, that will gives the characteristic color in the oxidizing and the reducing flames. In oxidizing flame, if it is copper, while the flame is hot, you will get green color, and if the flame is cool, then if you take out of the flame, it is cool, and you will get blue in color, then it shows the presence of copper. So if it is iron, in oxidizing flame, while it is hot, it is brown in color, and when you take out of the flame, so you will get yellow in color. And when you introduce that with a metal salt, which is nickel, in the oxidizing flame, when it is hot, you will get violet color. When you take out of the flame, that is cold condition, you will get reddish brown in color. So this is said to be the borax bead test, where you can identify from the color of the borax bead when you introduce that in the oxidizing flame or the reducing flame. So the next one, it is actually charcoal test. And charcoal test is also so simple test, where you have to take a charcoal cavity. So charcoal is nothing but it is carbon. You have to take that cavity, and you have to add the metal salt into the cavity and add sodium carbonate into it, and you heat it strongly either by the oxidizing flame or the reducing flame. You have to directly introduce the flame into it. So what will happen? The metal, so that reacts with the carbonate and the sodium carbonate, and it gets converted into metal carbonate. And you are strongly heating that in the direct flame. So metal carbonate, what will happen? It gets converted into the metal oxide, and it will give out the carbon dioxide also. The metal oxide, from after you burn and you observe the color of the residue, you can confirm so the presence of some of the metal ions. So for example, so if the color of the residue after burning is white, but it glows when you heat it, it may be the presence of these salts, which is barium, calcium, magnesium, aluminum, or zinc. So I'll repeat once again. So when you directly introduce the flame, and when you observe the residue to be white and it glows when you heat it, so it may be the presence of barium, calcium, magnesium, aluminum, and zinc. So when you observe the color of the residue to be yellow while hot, and when you cool it, you observe the residue to be white, then it is the presence of zinc. And when you heat it, the color is observed as brown, and when you cool it, when you observe the color to be yellow, then it may be the presence of lead. When you heat it and you cool it, you observe the residue to be reddish in color, then it shows it is the presence of copper ion. So from this flame test, borax test, and borax bead test and charcoal test, from the color of the flame and from the color of the borax bead and from the color of the residue which is present in the charcoal cavity, so we can confirm the presence of some of the cations. And these are the preliminary tests we usually do to analyze what is the cation and what are the anions which is present in the given salt. Okay. So the next one, you can go and analyze for the anions and the cations, so using the wet test. And anions, we usually classify the anions as the weak group of anions, the strong group of anions, and the general anion, which is usually sulfate, SO4 2 minus. And how we usually analyze these group of anions. So say for example, if it is a weak group of anions, so it is the three anions which is present in that group, which is carbonate, sulfide, and nitrite. You can do the analysis and simultaneously you can go for the confirmatory test also. So if you take the given salt and a test tube and you add sulfuric acid, so you will get a colorless gas which is evolved from the salt. So then it shows it is the presence of carbonate. And when you pass the gas into the lime water, so that is a confirmatory test. Simultaneously we'll be doing. So when you pass that, so gas into the lime water is calcium hydroxide, CaOH twice. You will be getting a milky white precipitate. So which is nothing but, so calcium reacts with a carbonate which is evolving and it forms calcium carbonate. And that calcium carbonate is actually the white precipitate. And when you continue to pass this calcium carbonate vapors again and again, so more amount of this carbonate is getting dissolved, then the white precipitate which is formed, so it slowly starts to disappear, which means that it dissolves. So why it actually dissolves? So more amount of the carbon dioxide is formed, so which forms calcium bicarbonate, or it is said to be calcium hydrogen carbonate. And that calcium bicarbonate or calcium hydrogen carbonate is actually soluble in water. So that is why the milky white precipitate, it starts to disappear. So then this is the confirmatory test of the carbonate. So the next one, it is the sulfide ion. So how you identify that? So when you take that and when you heat it, you observe a colorless gas which is rotten in smell. So which is a bad odor. And if you get that smell, you can identify that as a sulfide ion. And confirmatory test, we will do it simultaneously. So you add little amount of the dilute sulfuric acid and you dip that with a lead acetate paper. So lead acetate paper, now it turns black because it forms lead sulfide. Sulfide is present in that. So you will get the sulfide reacts with the lead and it forms lead sulfide. And that lead sulfide is a black color precipitate. So lead acetate paper will be changed into black in color. That is a confirmatory test. So if it is nitrite, NO2 minus. So you take that nitrate salt and you strongly heat it. And when you heat it, you observe a light brown color gas which is evolving. Okay. So, and you add a dilute sulfuric acid, you observe this light brown color gas which evolves, intensified. And now you want to confirm that as a nitrite, then you have to go for the confirmatory test, which is said to be the brown ring test. So, or you can also go for the starch test. So, confirmatory test, usually we go for brown ring test. So, brown ring test is very easy. So, you have to add ferrous sulfate, freshly prepared ferrous sulfate into the metal salt solution, and you add sulfuric acid, concentrated sulfuric acid in drops. So at the junction of this ferrous sulfate and the sulfuric acid liquid, you will get a brown colored ring, so which is said to be the brown ring test. So why the brown ring is actually formed? So during this process, what happens? So you have NO2 minus, NO2 minus, right? So NO2 minus, it oxidizes to NO3 minus, and iron also get oxidized, Fe2 plus, that oxidizes to Fe3 plus. And this iron, it reacts with water which is present in the medium, and it forms a complex which is said to be hexa aqua iron 2 sulfate complex. So which is when this reacts with NO. So because this NO2 minus or NO3 minus, so during that process it is reduced by this iron into NO, nitrosyl group. And in that complex, one of the aqua ligand is replaced by this nitrosyl ligand, and you will be getting FeH2O5 times an NO as a complex. And that is said to be iron nitrosyl complex. And that iron nitrosyl complex is actually that brown colored substance, and that is formed as a ring. So that is a confirmatory test. We usually go for the to identify the presence of the nitrite. So the next one, so it is the strong group of the anions. So when you consider the strong group of the anions, mostly they are halogens and the nitrate. So halogens, chlorine, we go for the dry test itself, right? So you will be getting yellowish, greenish yellow vapors with a pungent smell. So pungent smell is nothing but it causes the irritation to your nasal tract and your windpipe. So then it is said to be pungent gas. And the confirmatory test for that is usually we go for chromyl chloride test. In chromyl chloride test, we take the salt solution and we treat that with potassium dichromate and concentrated sulfuric acid. And during that process, so it produces chromyl chloride, which is CrO2Cl2. So that is said to be chromyl chloride. And that chromyl chloride is actually reddish orange in color. And when you pass that reddish orange colored vapors into water, so you will be getting a reddish orange solution. So that is said to be chromyl chloride test. And from that, so we confirm so the presence of chloride. So if you pass it to the water, you will be getting reddish orange solution. Or if you pass that to lead chromate, you will get when you pass that to a lead solution, it will be forming lead chromate, which is yellow precipitate. So that is also act as a confirmatory test. And for bromide, so you will be getting reddish brown pungent fumes. So I told you how to distinguish between this nitrite, nitrate, and bromide, right? So you get a reddish brown fumes for all the three anions. But if you have a pungent smell, then it shows it is it's surely the bromide ion. So then for the confirmatory test of that, so we usually for that we go for chlorine water test. So that's what I have mentioned as brown layer in chloroform with chlorine water. So that is actually said to be chlorine water test. So we have to take water along with the chloroform. So since water is high density, it stays down, and chloroform, so it is organic solvent, it stays up. So you have, it is a heterogeneous system, and you add chlorine water into it and you shake it strongly. And this chlorine, what it will do? It will oxidize this bromide ion into bromine, and you know bromine, color of the bromine in water is actually so brown, reddish yellow, reddish brown in color. And the water layer will change into reddish brown in color, then it shows the presence of bromine. That is said to be bleaching water test, or it is said to be chlorine water test. So the test for iodine, when you heat it, you will get iodine vapors. That time itself most probably will confirm. But the confirmatory test, anyhow, we have to show. Again, we can go for that bleaching water test or the chlorine water test. So which is nothing but you take chloroform, chlorine water, and water along with the salt solution, and you shake it strongly, and this chlorine will oxidize that I minus iodide ion, and iodine I2 will be liberated in the water, and iodine is violet in color. The water layer will become violet, so then we can confirm the presence of iodide ions. So or simple, if you want to go for the very simple test, you take the salt solution and you add a little bit of starch. The starch and iodine, it will form a complex which is blue in color. So that is also that also can be used as a confirmatory test for iodide. So the next one, it is nitrate, NO3 minus. Actually here also you get brown color fumes, but you can easily distinguish. If you just observe a light brown fumes, it is actually nitrite, NO2 minus. So if it is brown fumes but intensifies when you add copper terminates, then it is actually nitrate. You get brown vapors with pungent fumes, then it is bromide. Okay, easily you can distinguish from the wet test analysis itself. And the confirmatory test for NO3 minus is also again the brown ring test, as I told you. So you take the salt solution, add potassium ferrous sulfate and concentrated sulfuric acid. So what will happen? I told you, one of the aqua is replaced by the nitrosyl. That NO3 minus is now reduced to NO, nitrosyl group, and that aqua is replaced by that nitrosyl, and you will get a complex, and that complex is actually brown in color, and you will get a chocolate brown precipitate, or you will get a brown ring. So from that you can identify the presence of copper. So the next one I told you, so it is a very common group which is said to be sulfate, right? The analysis of sulfate, so is very easy. So you take the salt solution and you add dilute HCl and barium chloride. So if you add barium chloride, so it forms barium sulfate because the anion is sulfate, right? And this barium sulfate is a precipitate, so which is actually white in color. And if you observe this white color, so then you can confirm that. So the presence of the anion is actually sulfate. So you can classify these anions into different groups like the strong anions, weak anions, weak group of anions, and the general common anion, which is said to be the sulfate. So next we'll move on to the analysis of the cations. So when you go for the cation classification, we classify the anions into three simple groups, right? But we classify the group of the anions into seven different groups. So in that seven different groups, we start from zero, first group, second, third, fourth, fifth, so and sixth group of cations. And for each and every specific cations, so we have to move in the chronological order. So because the presence of one of the anion will interfere with the analysis of the other anion. So you have to follow the chronological order for the analysis. So the first is the zeroth group. So zeroth group, you can make it separately. So zeroth group analysis, you can most probably you will identify from the wet analysis itself. No need to go for classification. But in classification, we usually go from first group to the sixth group of the cations. So when you consider the zeroth group of cation may be present as in your salt, then you have to take the salt, you add sodium hydroxide, so and strongly heat it, and you observe a gaseous, colorless gaseous substance which smells like ammonia. So it smells like ammonia. So ammonia, it has a slight pungent odor. I already told you. So it causes irritation to your nasal tract and the windpipe. So it is the presence of the zeroth group of the cation. And if it is a first group of cation, so from your syllabus it may be lead. So the first group reagent is actually dilute HCl, and you add dilute HCl to the salt solution. So you will be getting a white precipitate. Then it may be lead chloride, the presence of lead chloride. So when you don't get any precipitate here, then it may be the presence of the second group of cation. So what you have to do, you have to add again some amount of HCl and you add the reagent hydrogen sulfide. And the second group of cation from your syllabus, it may be carbon, and you will get, if the second group cation is present, you get a black color precipitate which is due to the formation of copper sulfide. And if you don't get any precipitate in the second group, then it may be absence of that, and we move on to the next group analysis, which is the third group analysis. And you take that solution, you add ammonium hydroxide. So initially you add acid, right, HCl. Now you have to neutralize that with ammonium hydroxide and add the reagent as ammonium chloride. So if you have the third group, so from your syllabus it may be either the iron or aluminum. So if you have the cation, you get precipitate as, so now the reagent is actually hydroxide and chloride, right? So it will be precipitated as hydroxide, and it may be iron hydroxide or aluminum hydroxide. You will either get the reddish brown color or a white color precipitate. Then it shows the presence of third group of cation. So if you don't get any precipitate here, then it is absence of the third group. Then we will move on to the next group of analysis, which is the fourth group of analysis. And here again you have to add more amount of the ammonium hydroxide and make the solution basic, and the reagent you add is hydrogen sulfide. So then if you have the fourth group, so it precipitate as, so fourth group cations are nickel and zinc, right? So you'll be getting either nickel sulfide or zinc sulfide, so which is actually black and a white precipitate. So if you don't get any precipitate here, then again it is absence of fourth group. We move on to the fifth group. So here you add again more amount of ammonium hydroxide to make it basic, and you add the reagent to be ammonium carbonate. So here, so the metal ions, most probably from your syllabus it is barium and calcium, and this will precipitate as carbonate from the reagent, barium or calcium carbonate, which is a white precipitate. If you get white precipitate here, you confirm it is the presence of the fifth group. But if you don't get any precipitate, it may be the sixth group of the cation. So here, what we have to do, you add more amount of ammonium hydroxide, ammonium chloride, and now the reagent is disodium hydrogen phosphate, which is said to be the sodium biphosphate also. So that you'll get magnesium ammonium phosphate, so which is actually white in color. The reagent is disodium hydrogen phosphate, and it forms, if magnesium is a sixth group cation, you'll get it as, so magnesium ammonium phosphate, which is white precipitate, then it shows the presence of the sixth group cation. So if you don't get any precipitate here, you go and analyze for the zeroth group and show the confirmation of the zeroth group. Or you initially do the zeroth group and confirm whether it is present, or if you don't have any zeroth group, you go for the analysis from the first group. And you somehow get the idea about the presence of the cation. So if you assume that this may be the cation, so which is present as your given salt, then we have to go for the confirmatory test. So you have to show the confirmatory test for each and every cation. So say for example, so if you have the ammonium, that is zeroth group cation is present, then you have to take the salt solution. So add sodium hydroxide. I told you already, you will get a pungent smelling colorless gas which comes out, right? The confirmatory test is, here it is. You dip a glass rod in HCl and introduce into the mouth of a colorless gas which is evolving, and you will get a white dense fumes. So still the fumes intensifies, and when you cool that rod, so in the atmosphere, you will get white precipitate forms on the glass rod. Then it shows the presence of ammonia, because you did that in HCl solution. The evolving gas is actually ammonia. That ammonia, it reacts with the chlorine and it forms ammonium chloride, so which is nothing but the white color precipitate. So the next one, it is a Nessler's reagent test. You add Nessler's reagent and you will get a brown color precipitate. That is also a confirmatory test. But when most of the schools were not available to provide the Nessler's reagent, but we have the simple test, which is said to be the dipping a glass rod in HCl and introduce into the mouth of the pungent smelling gas to get a white precipitate. So that is a very good confirmatory test for the ammonium ion. So the second, it is the presence of the first group of the cation, so which is actually lead. So if you get a precipitate there, so it shows maybe the first group cations are present. And if you want to go for the first group cation from your syllabus, it is only the lead, right? But we have to show the confirmatory test. The confirmatory test is, you take the salt solution and you add potassium iodide. So what happens? You will get lead iodide as a substance, and that lead iodide is actually a yellow precipitate. So that shines like a crystal. We usually say that test as a golden yellow spandrel test. So in Tamil we used to say jigana, right? Where you get a golden yellow spandrel. So that precipitate is actually a shining yellow crystal. So that is a confirmatory test for lead. Or we go for that chromite chloride test. You treat that with potassium dichromate and potassium chromate. So it will form lead chromate. And that lead chromate is actually a yellow color precipitate. From that also you can confirm the presence of lead. So the second group cation, it is actually copper. So if you get a precipitate in the second group, so it confirms the presence of second group cation. Actually, second group cation is, again, it is only one, which is copper. And a confirmatory test we usually go as, so you take the salt solution and dissolve that in nitric acid, and you get a blue color solution when you add ammonium hydroxide. You add a few drops of nitric acid and you add ammonium hydroxide solution, it turns into blue. Actually, it is due to the formation of a complex, so which is said to be tetraamine copper 2 complex, which is CuNH3 4 times. That ammonium will react with copper and it forms a tetraamine copper 2 complex, which is CuNH3 4 times complex. So that is actually blue in color. Or you can go for the next test also. So that is a very common test we usually know. So which is said to be chocolate brown. So chocolate brown precipitate. So you take potassium ferrocyanide and acetic acid, and this results in the formation along with your metal salt solution. So that potassium ferrocyanide is actually K4FeCN 6 times, right? So now that complex potassium ion, the counter ion is actually potassium, that is now replaced by the copper which is present in your metal ion, and you get a copper hexacyano ion 2 complex. Now that is actually chocolate brown in color. So potassium hexacyanoferrate 2 complex is actually a blue in color. So now that Prussian blue, now that has been changed into chocolate brown color because the counter ion potassium is now replaced by the metal ion which is present is copper. So from that also you can, that is also a good confirmatory test for the presence of copper. So the next group cation is actually iron, and an iron, so if you get a precipitate, it may be either iron or aluminum, because in your syllabus you have two ions from the group 3, which is iron and aluminum. So if it is iron, so the confirmatory test we usually go as the formation of that potassium, so ferrocyanide complex, right? So you add neutral ferric chloride and HCl, it actually forms potassium ferrocyanide, that is K4FeCN 6 times, it is actually blue. But when you shake the test tube, it usually dissolves. Then again you add, so ferric chloride, now the potassium is replaced by iron. So here the potassium is replaced by copper to form the complex, right? Copper ion complex, which is chocolate brown in color. So similarly there, the potassium is replaced by iron, so which is said to be ferri-ferro complex. And that ferri-ferro complex is actually Prussian blue in color. So that is a confirmatory test. Or instead of if you add iron thiocyanide complex, so iron thiocyanide complex, now that will become, so iron potassium thiocyanide. If you add potassium thiocyanide, so iron will be replaced by that potassium and it will get iron thiocyanide complex. That iron thiocyanide complex is actually blood red in color. So either you add potassium ferrocyanide and observe a Prussian blue in color, potassium ferrocyanide and ferric chloride, and you get Prussian blue and confirm the presence of iron. Or to a salt solution, you add potassium thiocyanide and that potassium is replaced by iron to get iron thiocyanide complex, which is blood red in color. These two are confirmatory tests. If you get the negative results for these tests, then it may be on aluminum. So if it is aluminum, so you add excess of sodium hydroxide, it will form sodium aluminate, so which is actually a gelatinous, white gelatinous precipitate. So that is a confirmatory test. And the next group of cation is actually the fourth group of cations, right? So fourth group of cations, again you have two different types, two different ions here, so which is zinc and nickel. So how we distinguish between the zinc and nickel? So if it is zinc, so you take the salt solution, you add sodium hydroxide, you will get a white precipitate which is due to zinc hydroxide, and this is soluble in excess of that sodium hydroxide. If you add excess of sodium hydroxide, so that will get dissolved. So then that is a confirmatory test for zinc. For nickel, it is very easy to identify. You to the nickel salt solution, you add DMG, so which is said to be dimethyl glyoxide. It is actually very good ligand, and it, along with sodium hydroxide, because the solution should be basic for the formation of that complex, you get a rosy red precipitate. So it is a pinkish red precipitate, so which is a nickel DMG complex. So that is a confirmatory test for nickel. And if it is a presence of the fifth group of the cations, it may be either barium or it may be the calcium. So barium or calcium, both of them happens to be the white precipitate, right? So you try to dissolve that precipitate in acetic acid. So if it dissolves, then it is actually so barium. And you take that solution, you add ammonium oxalate, you get white precipitate, then it is actually calcium because it forms calcium oxalate. But the best method to distinguish this barium and calcium is a flame test. So we initially saw the preliminary test, right? So if you get if it is barium, you will get apple green color flame, And if it is calcium, you will get a brick red color flame. So that is the best conformity test for this fifth group of the cations. And if it is sixth group, so the test what we say there is that conformity test actually. So you add disodium hydrogen phosphate and ammonium hydroxide, you will get, I told you it is magnesium ammonium phosphate, right? And it is very characteristic precipitate. It is actually crystalline. You will get the crystals as long needles, a needle-like crystalline substance. So that is a confirmatory test for the presence of magnesium also. Okay. So this is considered to be the analysis of your cations and the anions. And some of the conceptual questions. So here we need to answer. And we will discuss some of the previous year asked the question. So from the examinations. Okay. So some of the conceptual questions we'll address first. So you see the first question: why you have to add HCl before passing H2S in the group 2? So they are asking why before. So why? So why before passing H2S you have to add HCl? This is the question. So you see, HCl, H2S is the group reagent for second group of the cation as well as the fourth group of the cations, right? So what is the fourth group of the cations? So here, so it is actually zinc as well as the nickel, right? If you add H2S here, if the fourth group cation is present, whether it won't precipitate in the group 2 itself rather than precipitating in the fourth group. So now here, if you add HCl, what happens? So it will increase the concentration of the common ion. Say for example, if it is H2S, how it dissociates? It is 2 times of H plus plus S2 minus ion. And here we add HCl also. HCl dissociate into H plus and Cl minus ion. So now, if the concentration of the common ion increases, that is what we learned in the equilibrium chapter as common ion effect, right? So if the concentration of the common ion increases, what will happen? The equilibrium will shift towards the left, and you will have more amount of the hydrogen sulfide rather than this sulfide. So what happens? The sulfide ion concentration will be less. Okay, so sulfide ion concentration is less, and if the KSP is less, then that substance will be precipitated. So second group cations. So what is the second group cation? So which is actually copper, right? From your syllabus. That copper alone will get precipitated here, and your fourth group cations. So that is your zinc and nickel. It won't precipitate here because the KSP value for that is very high. So since you have low concentration of sulfide ion, low KSP salts will be precipitated here. Okay. So this is the conceptual question. These kind of conceptual question you have to be addressed in the examination. So similarly, you look into the second question. Why you have to add ammonium chloride? So before ammonium hydroxide in group 3. Again, it is the same concept. If you add if you add more amount of the ammonium hydroxide, then what will happen? The fourth and the fifth group cations, so even the sixth group also will get precipitated. So if I increase the concentration of the common ion by adding ammonium chloride, then what will happen? The equilibrium will shift towards the left, and you will have very less amount of the OH minus ion here. If you have the low amount of the hydroxide ion, only the low KSP salts will be precipitated. So only the third group cations, that is iron and aluminum, will get precipitated. Otherwise, so if you don't have ammonium chloride, so hydroxides of zinc, calcium, barium and magnesium will be obtained, and you will get confused. So which group of the cation is present in your given salt? Okay. So you look into the next question. Why is magnesium not precipitated in group 5? Again, it is the same answer. What we are doing? We are adding ammonium carbonate. Again, by adding ammonium carbonate by common ion effect, we suppress the concentration of the carbonate ion. So, along with the ammonium carbonate, we are adding ammonium chloride also. So, common ion effect. So it it suppress the amount of the carbonate ion, and that carbonate ion, since the carbonate ion is less, only the low KSP salt like your zinc and the fifth group cation like calcium and barium will precipitate as carbonates, and magnesium will not precipitate in that. So for all these kind of question, the answer is only one answer, so which is said to be the common ion effect. So these are some of the conceptual questions. Yes. So we will look into some of the important questions, which is asked in your in the previous examinations. Yes. So we will discuss some of the questions. So from MCQs from the previous examination. Yes. See the first question. In the borax speed test, which of the following compound is formed? So I told you, right? It is actually metaborate. So what is a reaction? I told you. So sodium borate. So sodium borate is actually Na2. So Na2 sodium borate. Na2B4O7 dot 10 times of this water. So this is actually borax. So this is said to be borax. I told you we will strongly heat this. When you heat this, the water of crystallization will get removed, 10 moles of water will get removed, and you will be getting a sodium metaborate with boric anhydride. Sodium metaborate is NaBO2, sodium metaborate and boric anhydride. And the mixture of these two, sodium metaborate and boric anhydride, and the mixture of this is actually glassy bead. And to this, glassy bead formation, earlier you add the metal salts, right? So metal oxide, then you will be getting that metal, metaborate. And that metal metaborate, actually you wrote it twice, metal metaborate. And the metal metaborate will be various colors. So how you identify from the borax bead test? Actually, it is the formation of metaborate. So that is the answer. Yes, I hope I made it clear. So we will move on to the next question. So next question, sodium sulfide on heating with dilute HCl, it liberates a gas, sulfide. So sulfide, you check, turns lead acetate paper black, acidified potassium dichromate paper green actually, and burns with a blue flame, so smells like vinegar. Actually, if it smells like vinegar, actually that is not actually inorganic analysis. So it is actually organic analysis. I hope you would have remember the acetic acid, that is CH3COO minus. So that will smells like actually vinegar. It burns with a blue flame. So then it is the presence of copper, right? Sodium sulfide is a salt here. And it turns lead acetate paper black. Then it should be the presence of lead. And all these options are wrong because the salt is actually sodium sulfide. Then automatically, so which is the right option? So this is the right option. Okay. So how it is so? So you have sulfide, right? So when this undergoes reaction, obviously since it is sulfide is SO3 minus. Obviously this liberates sulfur dioxide. And it turns a potassium dichromate actually green. So potassium dichromate is actually K2Cr2O7, right? Here the chromium is in plus 6 oxidation state. And when this undergoes reaction, it undergoes reduction into Cr3 plus ion, which is in plus 3 oxidation state. In plus 6, it is orange in color, and it is in plus 3, it is actually green in color. So it turns acidified potassium dichromate green. That is the correct option because this is a sulfide salt, so it usually it undergoes oxidation, and during that process, it reduces the chromium from plus 6 to plus 3 oxidation state. I hope I made it clear and you understand this. We'll move on to the next question. See, two gases when mixed gives white dense fume. Then the gases are. That I already told you. So it is a confirmatory test of ammonia, right? So confirmatory test of ammonia. So we see when you dip a glass rod, so which contains when you dip the glass rod in HCl and introduce into the colorless flame, which is liberating, it forms a white dense fumes. The fumes increases and you get a white precipitate, right? So it is due to the formation of ammonium chloride. So option 3 is the correct answer. So it is ammonia and HCl. So next question. NaCl, that is a salt solution you have, and you are mixing that with potassium dichromate and concentrated sulfuric acid. Which of the statement is correct? So now that what we learned as chromyl chloride test, right? So when you mix that with potassium dichromate and concentrated sulfuric acid, you get chromyl chloride, which is CrO2Cl2. So this is chromyl chloride. And this chromyl chloride, so it is actually deep red vapor, which is actually what? And vapor in NaOH, it gives, yes, if you pass that in sodium hydroxide solution from sodium chromate, which is actually yellow solution, and chromyl chloride is formed, that is also correct. Here, chlorine gas is not evolved. So, which of the statements are correct? A statement, B statement, and D statements are correct, and C statement is actually incorrect. So we'll move on to the next question. See, sodium nitroprusside, when added to alkaline solution of sulfide ion, it produces a purple color. So it is due to the formation of. Actually, this is as a qualitative analysis of the inorganic ion. So for sulfide ion, it is given as a confirmatory test. Actually, you have learned this already in the organic chemistry. Okay. So sodium nitroprusside. So actually, it is Na2FeCN 5 times. It is NO. So sodium nitroprusside is actually Na2FeCN 5 times NO. Nitrosyl group will be there. And this nitrosyl group is now replaced as NOS in GAN. Nitrosyl NO group is now replaced by thionitrosyl group, NOS. And due to that, so the color, it changes into purple. So what is the correct answer? So this is the correct answer. So it changes into my Na2, now it has changed into Na3. So that formula you have to remember. It is Na3FeCN 5 times NOS. So it is due to the presence of that sulfur. So this is the confirmatory test for sulfide. So the next question, nitrate is confirmed by the brown ring. The brown color of the ring is due to the formation of, I told you, it is iron nitrosyl compound. So complex, right? So you have 5 aqualion. So Fe, actually the complex is, so Fe, H2O 6 times SO4. So this is the complex. So hexa aqua ion complex. And here this nitrate NO3 minus. Now this gets converted into a nitroside. It reduces to nitroside. Now what happened? One of this aqua is now replaced. How it is replaced? FeH2O 5 times and one is replaced as this nitroside. So it becomes ion aqua nitroside complex, and that complex is actually that chocolate brown color, and it is due to the formation of this ion nitroside and sulfate complex. So option 2 is the correct answer. Yes. So the next question. When carbon dioxide is passed into lime water, it turns milky. When excess of carbon dioxide is passed, the milkiness disappears. And I have already answered this question while discussing the confirmatory test itself. So first, initially what happens? The calcium carbonate is formed, which is a milky white precipitate. And again, the more amount of the carbon dioxide is evolving by heating the substance. This calcium carbonate reacts with the excess of this carbon dioxide and it forms. So calcium bicarbonate, or it is calcium hydrogen carbonate, so which is actually soluble in water. And since it is soluble in water, so it disappears. So second option is the correct answer. Water soluble calcium bicarbonate, that is calcium hydrogen carbonate, is formed. Okay. So the next question, when acetic acid and potassium ferrocyanide. So in other words, so if you want to give the name of that compound as impact nomenclature, so this hexacyanoferrate, potassium hexacyanoferrate complex is added to a copper salt. A chocolate brown precipitate is obtained. So it is due to the formation of which compound? So it is copper ferrocyanide, right? That's already I have mentioned. So this potassium ion is replaced by now copper ion. It is copper ferrocyanide, and that copper ferrocyanide is actually chocolate brown in color. So what is the role of nitric acid in group 3? So actually, so before analyzing, taking that centrifugate and you go for the analysis of the group 3 presence. So before adding that reagent, so what is a group 3 reagent? So group 3 reagent is actually ammonium hydroxide and ammonium chloride, right? So before adding that, you have to add nitric acid and you have to strongly heat it. Because, so most probably that group ion, either it is iron or aluminum, right? If it is aluminum, it doesn't interfere in any of the cases. But if it is iron, so iron has a two stable oxidation state, which is Fe2 plus and Fe3 plus. And most of the case, it fluctuates, it oxidizes and it gets converted to Fe3 plus and it reduced to Fe2 plus. Both of them are stable states. So along with Fe3 plus, this Fe2 plus will also present. But if it exists as Fe2 plus, it will surely interfere in the analysis. So you have to eradicate all that Fe2 plus and convert that into Fe3 plus. So in order to oxidize that, you have to add some nitric acid and you have to boil that. So before the analysis. Yes? So the next question, so 10th question. Hydrogen sulfide, so precipitate of copper, zinc and cadmium. So H1 will precipitate sulfides of copper, zinc and cadmium from their chloride solutions. If the solution is acidic, you know very well, because the reagent, first group reagent is actually HCl. I told you, due to common ion effect, what will happen? So the concentration of sulfide ion will be less, only copper will be precipitated in the second group. So if you didn't add the acidic, if you don't make the solution acidic, what will happen? Zinc and cadmium along with that. So the fourth group, all the cations will get precipitated. So due to common ion effect. Yes. So you see this X is a compound and you treat this with sulfuric acid. It produces white, which is a colorless gas with irritating smell. Okay. And so second, you have Y. You treat that with potassium dichromate and sulfuric acid, you get green color solution. and identify this X and identify this Y. Just now I have told you. So chromium, if it has to get converted into green color solution, from +6 it has to get converted into +3, right? So then what should be the substance that is? I told you, it should be either sulfide or sulfate. So or sulfur dioxide. Then what is the correct answer? So first option, only in first option, this Y is given as sulfur dioxide. Okay. So sulfite is the one which produces the sulfur dioxide, and this sulfur dioxide, so sulfite is the gas which produces sulfur dioxide gas, which is a colorless gas which causes irritating smell. Okay, so the option 1 is the correct answer. So next question, why ammonium carbonate instead of sodium carbonate is added in the group 5? So why you have to add ammonium carbonate, not the sodium carbonate? Sodium carbonate is also the reagent, right? Why you are not adding the sodium carbonate? Okay. So if you add sodium carbonate, so what will happen? It's not actually why you are adding ammonium carbonate actually? Due to common ion effect, the concentration of carbonate will be less. Only the fifth group cation will be precipitated. If you are adding sodium carbonate, then common ion effect is not maintained. So then, along with the fifth group of the cation, that sixth group of the cation, magnesium will also precipitate as magnesium carbonate. Then it will interfere in the analysis. That is why we are adding ammonium carbonate. Dimethyl glyoxide, so that will give a rosy red precipitate for the presence of. So just now we have learned that, right? So it is actually nickel. So nickel DMG complex is at that rosy red precipitate. So which is the confirmatory test of the fourth group cation. A white precipitate soluble in excess of sodium hydroxide confirms the presence of which ion? Actually, it is chloride. So you why it's actually soluble? Because it forms that silver chloride. All of them will give 5 precipitate. Okay. So when you add the reagents, it forms a silver bromide or silver iodide or silver chloride. So silver iodide and silver bromide is actually yellow color precipitate, and silver chloride is white precipitate, and so the sulfate is also white color precipitate. But when you add ammonium hydroxide, this dissolves. So silver chloride actually, when it reacts with ammonium hydroxide, it forms a complex which is silver amine complex, AgNH3 twice plus silver amine complex, and that silver amine complex is actually soluble. So from that we confirm the presence of chlorine. Okay. So this is assertion and reasoning type of question. See, assertion, sodium is the flame, sodium flame color is actually yellow. And the reason they have given is sodium has low ionization energy. Yes, this assertion and reason, both of the statements are correct, and it is a correct explanation also. So because sodium, it emits in the very low energy region, so which we have the wavelength of 589 nanometer. Okay, so it has very low ionization energy. That is why it gives yellow color. Okay, so it lies in the low region. Yes. So these are the most probably asked question. So from the previous year. So I hope the session has been useful to you. And May 2026 paper, nearly about so 3 questions you obtained from. So you observe from this inorganic qualitative analysis, and so I hope this session would have been useful to you. And best wishes for your re-NEET examination. Thank you.